we have Jason Doherty here with us. Jason is actually a Slalom alum. He's now working at 60 Hertz, setting up their microservice, or kind of leading their...
Microgrid.
Yeah.
We actually do microgrid software with microservices.
There you go. We'll learn all about it. And next month, we have Brett Mitchell in. He's going to be doing a fun blend of IoT and Space Invaders. So it's going to be a really fun talk. I highly recommend you come. But without further ado, I'll let Jason take it away.
Hi, everybody.
Hi.
Thanks, Ricky. So I'm Jason Doherty. I am the CTO at 60 Hertz Microgrids. As Rosie mentioned, I was a consultant here at Slalom, and I actually spent a lot of time looking at customers and their microservices systems and figuring out all the inventive ways in which they could fail in production. So I actually learned quite a lot of things from watching customers, and we've been trying to use them a little bit in work at the moment, and so we've got quite a few lessons learned as well. Just before I get started, who here has used microservices before? Ooh, almost everybody. Yay, cool. All right, so my little thing gonna work? Yep, there it is. There's a picture of my dog, just because I like to figure out how to get a picture of him into the different talks. But we are going to focus a little bit on a doggy daycare service as we talk through things today. So that's the dog. When we talk about the dog service, it's him. All right, so the very first thing is microservices, more than anything else, is an architectural pattern. It is just a way of building software. It's nothing more than that. It's nothing less than that. There's no magic to it, except for where there's lots of magic to it. But the main thing to remember is sometimes microservices are the right answer. Sometimes microservices are not the right answer. More often than not, they're probably not. You have to have one of the problems that microservices solves in order to want to actually do microservices. So, quick idea for what microservices are. In a monolithic application, which is the ones that we're all used to kind of building, you have a single node application that has things like invoices, accounts, dogs, check-ins, and all of those different features of your application are all run out of the same process, the same code base. Usually one database, sometimes a couple of databases. It's pretty straightforward. And that is what we typically call a monolith. On the other hand, with microservices, what we do is we take every single one of those different features of our application and we break it up into smaller components. So invoices and dogs and check-ins and accounts all become their own services. And then some kind of magic thing in the front end, that's the blue magic thing there, figures out how to get our requests to go to the right places. We're going to talk about all the magic things. One of the nice things about microservices is you can use whatever language you like, and you can mix languages. You can also mix databases. And so you can find the right tool for the job as you're actually building your services. So for example, if I find that Python, I need to have like a heavy data analytics component, or I just like Python, or it does something particularly that I need in one particular use case, I can use Python for that service. My dog likes Python, so that's why we use it there. With MongoDB, I can use that in multiple places, but the key thing here is that we're not sharing data between the services. Each service owns its own data end to end, and that's one of the key parts of what makes something a microservice versus just distributing your monolith across a bunch of processes. I actually looked up microlith, and that's what came up, so it's actually a thing. There's another architectural pattern that I would recommend highly that everybody looks at, because my understanding is this is how Amazon.com is built, and Netflix and a few other places are actually built, is they use a composable UI where the team that builds the microservice also builds the front-end components. And so each of the front-end components is talking to the back-end. And so they own the end-to-end experience for the user for that particular piece of the puzzle. And I've got a link to a cool article in the end that you can go read up about that. But actually having a composable micro UI is actually taking it one step, possibly too far, but depends on your scale and your problem and what you're trying to solve. So basic concepts, very small components. They model a business domain completely, and we're going to talk about that quite a bit later on. They're independently deployable. So every one of these services I could launch and run completely independently. Loosely coupled, basically that means that the services don't have a lot of dependencies on each other, and they try to act as independently as possible. They own their own data. That is probably the key for me, and the key thing that if you're going to try to build a monolith that can be refactored into a microservice later on, that's the one thing that you have to get right, is separating your data. And they scale well to multiple teams, and that's actually key. We're going to talk about that quite a bit. And then it's a distributed architecture. We're going to talk about that quite a bit. So, important stuff. Monolith is a design pattern. Microservices is a design pattern. Choose the right tool for the job. So, in my current role, we actually went microservice-y-ish to too much of a level early on, and we got it wrong. Microservices is very hard to do if you're starting in a greenfield scenario and you don't understand your domain. You'll end up having to go back and refactor and rewrite and move things around. So a lot of people, me included, recommend starting with either a monolith or very coarse-grained microservices, and then eventually move your way into microservices when you have that problem that they solve. So this quote, couldn't actually find who it came from, I just memorized it. Microservices are a cost you may want to incur to obtain great benefits. They come at a cost, they have great benefits, and the costs are huge, but the benefits are huge. So another important thing, monolith does not mean legacy. A lot of people hear the word monolith, and I'm like, oh, I can't build a monolith. I actually think you should build a monolith almost all the time. First of all, once you understand your problem and you have a scaling problem with teams or people or with the service availability, then you can look at refactoring at some point. But a monolith just means all the code's in one place. Shared, you can reuse stuff. Refactoring's really easy because all the code's in one code base. So, and you can have a well-architected monolith. So I don't want anything that we're saying today to be like, oh, you have to do microservices because otherwise your architecture is bad. Bad architecture is bad architecture. And I've seen some terrible microservices, bad architectures as well. All right. So one of the advantages of microservices is that you can assign them to different teams. It took me a little while to Google teams that all had beards in them, but apparently developers' teams all have beards of some kind. Yeah, here. So he's got an epic beard. Allow teams to release services independently. And that's probably the main reason to use them. I have 10 teams, I have 10 services, they can work independently of each other, and they can release independently. And it's actually decoupling the people that's probably the number one reason you want to use them, unless you have some kind of crazy Netflix scaling problem, which none of you probably do. And if you do, I don't know why you're at this talk. So one of the big things is no release holdups. So I don't depend on SIG's team over here in order to release my software. I can release my software whenever I want. I have an API contract with the rest of the world, and pretty much I can do what I want whenever I want. I can release twice a day, once a week, whenever I feel like it. All's good. It's loosely coupled, so I don't get impacted by any other people's services. Once again, allows me to release frequently. And it allows me to scale up the number of teams that I have. So this is where microservices are really good. If I have 4,000 developers, and people in town do, and they're organized in teams of 8 to 10, I've got to figure out how to get 400 or 500 teams to work independently. And microservices are brilliant at that, and solving those kind of problems. So one of the big things with microservices is how big should a microservice be? So 1 or 2 services per team is what I've seen work pretty well as far as what I've seen in consulting. And also as I sort of researched around for this talk a little bit, it was generally 1 or 2 services per team. One team managing 10 services is probably bad. Apparently their team is doing it that way. We actually started, in my current role, we actually started by building 8 services where we really needed 1. But we do actually have a need for, like, I guess, mini services, not microservices, in that we probably need to be using different languages for different purposes and different databases for different purposes. So a good example would be something like an image service. Kind of doesn't depend on anything else. You stick images in, images come out. That's a good candidate for a microservice. You could write it as a Lambda for all anyone cares. Doesn't matter. It's very independent and loosely coupled and not tied to anything else. So those are really good candidates for microservices. Teams sharing a service introduces dependencies. So you've got two people in the same code base or two teams in the same code base that are now tightly coupled together. That would be, I guess, a mini monolith, if you want to look at it like that. But the main important thing is that the team owns the entire service. The code, database, CI/CD, testing, you name it, you own the whole thing. If it breaks, you fix it. If it breaks at 4 a.m., your pager goes off. You're still fixing it. So with microservices, you own the thing end to end. So the ideal size, it depends. So some microservices might be 100 lines of code long. Some microservices might be 100,000 lines of code. Just depends. So we've harped on a lot about this first one. Each service owns its own data, but they have to collaborate. And when they're collaborating, in general, you want to be using JSON or something that you can debug, because things will go wrong. And when they go wrong, you have to be able to read the logs. If you've got it in protocol buffers, you won't be able to read the logs. So you actually have to have your data transport layer in something that you can debug. The advantages of getting fancy with data transport aren't worth it versus the ability to debug the network. So I would definitely recommend just using the most plain vanilla thing you can find to get services to be able to talk to one another. The most important thing, no data sharing. Keep coming back to that. So what a lot of people have done in the past is they use the database as an integration point. So they'll have two different services and they communicate to each other by popping rows into the database. And the different service will go into the same database and pull some data out. In microservices land, that is completely verboten. You don't do that. The rest of the stuff on there, yeah, you can read it. But evolutionary architecture is actually pretty cool. The nice thing about microservices, it lets you actually evolve different parts of your system at different rates. And especially if you have 10, 20 different teams, different parts of your system can evolve independently because of microservices, largely because the code is completely separate. So this is a screenshot taken from a talk that I linked to down the bottom called Mastering Chaos. I would highly recommend this talk. It's from the reliability or head of reliability engineering who later got a promotion to something else at Netflix. This is Netflix's actual microservices infrastructure. They created a tool that will draw it. And this, in the actual talk, is all animated, and you can actually see the traffic moving in and out of the services. So if you're running something like Netflix, that's what it looks like. And that's the level of complexity that you have to figure out how to model. And that's the sort of thing that you can't really code that kind of stuff. You have to automate that kind of stuff. So yay, microservices. We can go really fast. We can work independently. Our teams can be autonomous. I don't have to worry what Sig's doing with his code. We're all good. So the hardest part of microservices is your data. And this is why I would actually recommend most people start with a monolith. So imagine that I have a doggy daycare service. So Dogly is a modern SaaS platform for doggy daycare owners who need to manage 2 or more facilities across the nation, handling invoicing, booking, sign-ups, and staffing in our easy-to-use modern mobile apps. Sign up today for your free 30-day trial of Dogman mobile app and blah, 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 blah. You know the pitch. So now I have to design this thing and just pretty simple requirements. Got to manage a few things, and I've got desktop, sign up, something to do with billing. So let's see what that involves. So obviously I need to model dogs. So maybe I need a dog service. I got pet owners. They're going to come into my stores. So they're going to have visits to my stores. They're going to book them in advance. So I have bookings. Now I've got stores to keep track of. I've got waivers, people signing out dog waivers. I want to keep track of those. That needs some kind of PDF signing thing. Billing and invoices, I want to get paid. Sales tax, if I'm going to be nationwide, taxes vary by state. Got notifications, emails, probably want to take photos of the dogs. I've got a scheduling service. Then I've got to schedule staff. Then I've got to probably handle vacations. That's a lot of services. Now, it's multi-tenant. Oh, sorry, every one of these things has its own database, by the way. And it's multi-tenant. So now I have to worry about customers, users, roles, and, well, apparently roles twice. So they all have their own databases too now. It's an interesting problem. Now I'm managing 19 services and 19 code bases and 19 databases at least. Now, if you're one team doing all of this, that's crazy pants. If you're 10 teams doing all of this, that makes a lot more sense. And you can sort of see why this math works for microservices being really good to solve a team problem, generally not to solve a code problem. It's very good at solving team problems and scaling problems. You probably don't have those kind of scaling problems, and you may have those kind of team problems. So, we have an interesting scenario now. I need to register a new user for a 30-day trial in a production environment. I've got to run at least 2 copies of all of these now, reliably in production. Think what it takes to register a new customer. I got to hit a whole bunch of services to make this happen. So, down the rabbit hole we go. So, one way to do this, and I've seen most places in Denver that I've worked with actually use this pattern, is every microservice just talks to every other microservice directly. So, that was me just taking a stab in the dark of what I think a registration service would look like. And I know this is about right because when we were looking at our app last month and we had to figure out how to do registrations, I refactored my 5 microservices down to 1 because I just couldn't deal with that. So the problem is going to be, yeah, there's lots of memes in this thing. So the problem's going to be that you're adding complexity by going down the microservices route because now you have to solve some interesting problems. What if the network goes down between these services or one of these services crashes? So how do you handle things like transactions? So what if something in the schedule service fails to create a default daycare schedule? How do you handle a partial transaction across that many services? So now you're going to be researching something called sagas. And now what you're looking at is you're going to have kind of like central service that's going to coordinate something like a registration across all these other services. And now you have to build this complicated logic for doing things like retries and failure handles and eventual consistency. So some of the advantages of doing something like this, you build a central coordinator that's going to go and call all of these services and keep track of what worked and what didn't, and then retry things that didn't work later if they weren't fatal. You have to write all this stuff. It doesn't come for free. As far as I know, I've not seen a good microservices environment for managing this stuff off the shelf that doesn't involve a ton of work. So you've got rollback capabilities now. I can do undos, multi-phase commits, but there's a big downside. The registration service now knows about the inner workings of every other service. It's an awful lot of coupling. So this actually comes from a book called Microservices Patterns. If you want to peek around different ways of handling long-running transactions in microservices, I would heartily recommend that book. It's also a good book to help you sleep. It's incredibly long and detailed. And he actually has a framework called Eventuate Tram, which is used for managing long-running transactions in microservices environments, but it's Java only. So another way of doing this and solving that same problem would be something like responsive programming or reactive programming, where you have a service that issues an event saying, well, the user registered, and it dumps it into a queue, and then comes back to the user and says, yep, I'm good, and the user goes about their business. That then kicks off an event that other things can listen to. For example, a customer's service could be listening to it. It subscribes to that event. Whenever it happens, it goes and creates a customer record. So instead of something telling it what to do, it just listens for events and responds to them. It then says, oh, look, I've got a customer-created event, and it publishes that back to the queue, and the email notification service is now subscribed for customer-created events. If it turns out that the email service is actually something that's like a bottleneck because sending emails is kind of slow, if you're using SendGrid, it'll be fast. If you're using anything else, it'll be slow. I like SendGrid. You can actually have multiple instances of an email service listening for the same message now. So I can actually have many-to-one scenarios. And so by using a queue, you can kind of hide yourself from the fact that these services have to be up 100% of the time, and you can allow for partial failures of services. So advantages, eventual consistency. Registering somebody will eventually succeed. If my service is offline, I can go fix it, launch the code, it'll pick up any events in the queue that it's waiting for, and then process them. It's completely decoupled. None of my services know about any other services. They only communicate with messaging. Downtime's cool. If it goes down, that's fine. Start it up again. Everything's good. Handles loads well, so I can scale it out really easily. And you can solve that. You can have that multiple listener problem. You can have multiple listeners listening for the same event. The customer created event might actually have 5 or 6 different types of services listening for that event. So, and the other thing, especially if you're using Kafka, is events can be replayed. So if you actually find you have a bug, you can actually roll back in your logs and actually replay all your events back in time. And that'll get you back to a good state. So it's part of the reason for keeping every single event ever is it allows you to replay them, work around bugs, replay scenarios in different environments. So huge fan of that if you can afford to run it. It takes like 9 servers to run it. Apparently these guys are running Kafka. Yeah, basically you find yourself reading a Zookeeper manual at 2 in the morning. So some solutions to this, Kafka, RabbitMQ, and most recently Redis. As of September of last year, Redis now actually has messaging streams and producer and consumer streams, and can actually do event-driven architectures really, really well. So that's what we're using because we can't afford to run Kafka. So, but Kafka's really good. So that leads us down into a different rabbit hole, which is domain-driven design. So the hardest part about microservices is figuring out where to draw the edge of where the microservices ends and the next one starts. And that's actually really hard to get right. So one of the things you want to avoid is nanoservices. And I tried to draw a diagram for this, but I really couldn't. It would be the equivalent of having an invoice service and an invoice item service and an invoice item quantity service and an invoice catalog service and have all these services try to do something like an invoice. That's just way too small. And if you find in order to actually commit a transaction, you have to talk to like 10 services, you're probably in the nano services kind of category. So you got to find the right size boundaries. So there's this concept called aggregates and bounded contexts that make really good service boundaries. I'm going to talk about that in a second. The other thing that's really good is your transaction boundaries. So if you find that something like committing a transaction or committing an invoice or something like that you have to commit something, those things usually make good places to put microservices. So a good example that I tried to come up with for this, was reluctant to show you our actual ones, but you could have a reservations context. So this idea of a bounded context is you have this idea of an area within which a team would own all of these things in theory. You could have individual teams own each one of these services, like the dog service, the facility service, the owner service, or you could just have a reservation service that has a reservations endpoint, a dog endpoint, a facility endpoint, and an owner endpoint. And the idea of a bounded context is everything that needs to change together is inside of that context, and then it just uses events in order to communicate to other contexts. So a good example, if you've got like a SaaS business, you might have an organization context, which would include your users, your roles, your customers, possibly your bills, customer billing information. You'd probably put that in a single context because all that stuff tends to stay together. So it'd be like a master customer record kind of idea. An interesting thing, if you look at this between the accounts context, which is all about finances, and the reservations context, which is all about managing dogs, I have a concept of an owner, like a pet owner, which is also my customer. And they're very similar. And one of the things you learn in domain-driven design, especially when you see this scaled out to 400 teams, is it's okay if you have duplicate data. In fact, you want to be okay with duplicate data because it actually decouples your system. So for example, you might have a customer bounded context that owns the master record for customers. But every other system, like an invoicing system, needs to know about customer address updates. So they just subscribe to notifications. Tell me when the address is updated, and I'm going to update my local record. That way at runtime, the services don't need to communicate. They have their own local copy of the data that's being cached and kept up to date. And this is where Kafka is brilliant at doing this kind of stuff. You can publish the message once, and anybody that cares can listen to it over time. And so effectively what you have is a concept of like a domain event, which says a dog has checked in, that generates an invoice event, or my address has changed, or a dog owner's added, that actually is an address event that has to go both directions. And you communicate using messaging. That's going back to that messaging pattern we talked about a bit before. So this is what domain-driven design actually looks like if you go and read the book. There's a book I would recommend if you're a beginner at this called Domain-Driven Design Distilled by Eric Evans. It's a newish book from 2 years ago or a year ago. It's bright green. Makes this really easy to understand because the actual book on domain-driven design is about that thick and it's really hard to read, and his new book is even thicker and even harder to read. So I would just definitely recommend the Domain-Driven Design Distilled book. Got a link to it at the back. It's awesome, and it explains how to go about finding the right boundaries and edges. So if I was approaching this with a small team, I would create 2 microservices, one for reservations, one for accounts, and I would make each one of these concepts that are in here a different endpoint in the service. If I was trying to approach this with 10 teams, I would actually break them up into 2 different major groups, and then I would actually give each one of these things to a different team, and then come up with the right events to be able to have them to communicate with one another. So it depends on how big your team is, how much money you have, how you go about building something like this. Yeah?
So, did you, for the 2 different groups doing the different contracts, how did you guys manage the eventing?
Use Redis in our case, but I've used Kafka before a bunch, works great. Used AMQP, RabbitMQ, SQS, just use a queue.
And then, did you guys use a ubiquitous language in all this?
We came up with a universal event structure, but it was really simple. It's just event name, event type, event date, which service generated it with a class and key, and then a blob for the data. And then the services would communicate using those events. So the event package was always the same. The contents varied depending on who was sending it and who was receiving it. Yeah. So you're still doing service contracts, but you're doing it on the event level. Yep.
So if you're passing all these events around between these microservices, eventually you're going to run into a situation where the producing service has now changed the schema of that event. Maybe there's additional info you want to pass over, maybe there's a typo in the code.
Yep.
Whatever, that schema of an event will change over time.
Yep.
How do you manage those multiple schemas when it comes to the dependent services? Because if the dependent services are consuming those, it needs to know basically about current schema and probably at least one back, potentially even further.
Yep.
So how do you handle that sort of code changes and schema changes within development environments so that it doesn't become unwieldy over the course of, say, 6 months?
Yeah, I don't actually address this in this talk, but that is actually one of the hardest parts of doing this. Generally, I try to not change the eventing schema as much as possible because that basically is the thing that will cause you the most pain and anguish. You will have to support multiple versions. There will be changes, like you said, typos. Generally, I try to get the teams to code it so that the receiving service is fault tolerant to different changes in messages. So if you're going to simply put a DTO up and try to deserialize, and if like there's one thing off, it fails, that's a pattern that's going to set you up for failure because your schemas will change. So what you want to do is build your listeners in a way that they can adapt to partially okay data and just ignore the things that are wrong, flag them as errors, and then you'll have to go through and fix them. And I would just definitely dump them in the logs and then have an alert that's mismatched schema and then go fix them afterwards. But generally it becomes on the consumer to actually be fault tolerant in that case. But yeah, that's a big problem. Okay. So, general recommendations. There's a reason I say start with a monolith and go to microservices, because once you start with a monolith, you actually know what your domain looks like, and you know where the edges are. And it's the edges that are the hard bits. They're great for decoupling bigger teams. They're not good for launching your startup. So don't use this in your startup unless you have a need to actually release things that are using wildly different languages for really practical reasons. Service boundaries are hard. Actually, communications between service boundaries are hard, even harder again. And yeah, ideal microservices have zero dependencies. Just actually on your point again, something else just occurred to me. That's one of the primary reasons to use JSON for your messaging structure and your payloads and also any of your communications, because you can debug it. If you use a messaging structure that's binary because it's fast, you won't be able to debug the thing. You have to be able to read it in a log because stuff will go wrong and you have to figure out how to debug it, which we're going to talk about quite a bit. All right, I got this from Martin Fowler. You must be this tall to use microservices. There is a minimum level of maturity in your organization that you will need in order to pull something like this off. Because once you actually run a distributed system, everything becomes hard. While I was Googling around for silly photos, I came across this, which I just don't get. Like, who thought that was a good idea? Anyway, so second hardest part of microservices is operating them in production. Running these things is stupid hard. To put it in context, I've had a DevOps guy who used to run a major website, which easily got 20,000, 100,000 customers a day kind of deal. He's been setting up my microservices environment for 2.5 months. This stuff is not trivial, and he's done it multiple times before, very experienced. There's a lot of things you got to get right in order to be able to pull something like this off, because things will go wrong, and that's where actually the problems start to happen. You can't just view a log and you're good to go. So there's a lot of micro abilities you need: deployability, availability, reliability, discoverability, scalability, maintainability, debuggability, and supportability. Does anyone not know what any of these things are? Do I need to define any of these terms before I keep on trucking? Okay. So you need to be able to do all of these things. In the case of our dog service, with 19 services and 19 databases distributed. Yes?
Actually, could you expound a little bit on, in this case, what discoverability of microservices is?
Yes. I'm actually going to cover that in quite a lot of detail, but it's the idea that if a service has to actually talk to another service, it can discover where it's going to be, because microservices will move around a lot and they will change a lot over time. Yes?
Actually, how about supported? What does that mean exactly?
Can you keep it running after your DevOps guy's contract runs out? That's the worry that I have right now. Can I keep my Kubernetes cluster running after he leaves? So I think I can. Don't know. I'll find out. But can you support it long term? This stuff is not free. This stuff costs you a lot of money. And you have to be able to get the benefits out of it to be able to pay for all of these things. So good example, the problem. The network is not reliable. So I make a request to a feature or a microservice. It goes and then calls 2 other microservices, but one of them times out. So now the transaction's going to fail. Or should it fail? Now I have to figure out, does feature A fail? Does it not fail? Sort of depends. Now I have to figure out how to actually figure out what's going wrong. But the network is super not reliable. So now I'm actually going to do something different. I'm going to post something to feature A. It's going to succeed doing a post to feature C. It's going to write to feature B. That request will get there. The object is written, but the response doesn't come back. And it might not be because the network went down. It could be just because you screwed up configuring a port. And if you think that won't happen, the demo I'm going to run at the end of today didn't work until about 10 minutes before I started because of a mismatched port. This stuff is real, really happens. So now I have to handle something like a timeout on a response where the request got through. Now I have to figure out how to debug something like this. So an interesting problem with your logs in this case, if you actually think through feature A's point of view, it's trying to register a dog, it's posted a dog to feature C timed out, the dog's not created. And that's because it has a timeout of 10 seconds. But feature B just happened to be slow in responding. Everything got created. The dog was actually created. but because of the slow response, this service C has a 30-second timeout, service A has a 10-second timeout. And now you have to wonder about timeouts across your service mesh. That becomes a real problem that have to collaborate to get something done, as one of my customers did last year. So all it takes is a failure deep down somewhere that's actually just a timeout, and it can cause all these interesting ripple effects where things did actually succeed, but you don't know about it. Now here's an interesting problem. How do you debug your logs in this environment? So now you have a distributed debugging problem. And so the solution to that is generally people use like Beats or Fluent and something like that. They'll shovel their logs into a common service like Logstash that'll take your logs and convert them into a nice pretty format. And then you dump them into Elasticsearch. And then from Elasticsearch, you can view your logs in Kibana, and then you can create a nice distributed log. There's other tools that do this as well. Jaeger is good at doing distributed tracing inside of a Kubernetes cluster. Dynatrace is awesome, but really expensive for doing tracing and distributed logging. And Datadog is also good. We are currently using Datadog at work, though, and if you are a small company, it is really expensive to run, like really expensive. We had a month where we had very little traffic, and we still got a $450 bill for like 10 users. It was nuts. For the logs that, if you actually correlate the logs with the users that generated them, it was crazy how much money we spent on logging for like close to no benefit. So Datadog can be really expensive because you pay on log volume, and it depends entirely on what you're logging. Anyway, the solution really is you have to be able to do centralized logging, and you have to be able to do distributed tracing, which means if you're sending a request through a large number of services, you have to have some kind of key that you can track across those services, like a request ID or a correlation ID or a transaction ID. Jaeger has a great format for that now Elasticsearch supports natively. So Elasticsearch has a new module called Elasticsearch APM, which is awesome. We're switching everything over to that. And Elasticsearch APM can read this stuff natively. Check it out. It's awesome. They released it like 2 weeks ago. All right, more rabbit holes to go down. So, nested service failures. If you think this doesn't happen, this happens to, as far as I can tell, just about everyone in town, just based on what I experienced as a consultant. At some point or another, you will have a service that will catch on fire, and it will stop working, and it will take out the rest of your services upstream unless you actually prepare for something like this. So we're going to talk about a few different ways that you can prepare for these kind of things. So you need monitoring to detect problems before your customers call you. And if you think everybody has monitoring, how stupid could you be? I guarantee you at least half of the big companies in town don't. One of the advantages of being a consultant, I get to see a lot of stuff. Alerting. You want to actually be alerted that there's a problem. And then the other thing we're going to talk about is circuit breakers and what they actually do to protect your services from failures like this. So, good example would be something like a metrics endpoint. So every one of my features has a metrics endpoint. It's got some data. And what I'm going to do is slurp that into a system called Prometheus, which is a time series database. And it basically allows me to poll a metrics endpoint every 5 seconds, 10 seconds, 30 seconds to pull back performance metrics from every one of my services to tell me how are they working. And then from there, I can produce nice little pretty graphs and charts in a tool like a nice UI. Kind of cool. Show some nice pretty pictures. You can also use some other tools that, as well to solve that kind of problem. And Elastic APM, by the way, this is an ad for them, which is really cool. Now automates all of that. They can slurp up Prometheus metrics and draw more for you. The other side of this is you need some kind of a health check endpoint, something other than just the service is up or the service is down. So that would be like a ping endpoint that responds with a pong or something like that. But you need something that's going to tell me is the database connection up or down. So for example, service C has lost connection to its database. So it's now offline, and you need to know about that. And so now you find yourself having to build health check endpoints into your code, and then you'd use something like Sensu, a million other tools, to suck all those health check endpoints in and then set up custom alerts and alarms. From there, you'll send out a Slack notification. I actually found one that had 9,999 Slack messages. And then something like PagerDuty to like email or send you a text message at 4 a.m. that you need to get up and maintain the Kafka cluster again. Apparently these guys have got a similar experience to mine. Or send you email first thing in the morning, which you have that silenced, of course, because who doesn't? Some other good tools, once again, Dynatrace, Datadog, and Elastic APM can do all of this stuff too. I'm a huge fan of Elastic APM because I don't like lots of tools. Having to look in 10 different places to figure out what's going on is really painful. But that's what most people's monitoring dashboards for microservices look like. Datadog and Dynatrace make it super simple. They're just both really expensive. Yeah?
Are your health checks public?
Sorry?
Are your health checks public?
I don't have them being public, no. You can make them public. A lot of people will use like status page and point that at their health check endpoints and then make status page public. So that's what we used to do at Cloud Elements. Worked great. So, if you're interested in the finer points, there's a book called Production Ready Microservices that came out that covers all of this stuff in excruciating detail. It's really good, and it makes you realize all the things you didn't do in your cluster and makes you kind of panic a little bit. So definitely worth reading, but keep in mind you'll probably find something in there that you should have been doing that you weren't doing, and it'll tell you all the creative ways that your stuff will fail. So you can have a service crash and restart without warning. So if your service now crashes in the middle, it's gone, and it's going to be on a restart, but it's going to take down all the other services. So this is another case where it hasn't it's just gone. It's not there anymore. So one of the things to keep in mind, this is a phrase that I learned on a rancher webinar once. Microservices are cattle, not pets. You don't want to get attached to any particular instance of your microservice. You've got to design your microservices so that every single one of them is stateless and can die and go away at a moment's notice, because that will probably happen. If you want to be clever, you might actually cycle all of your containers every day, so you actually always have fresh copies of your software running. So way back in the day, we used to do that with ASP.NET. We'd just get it to cycle itself every 24 hours because something would get kind of wonky, and just turn it off, turn it on again, work great for another 24 hours. That worked for me for 4 years. So services will die somewhere further down the stack. That is really strange. Anyway, routing and service discovery. Who here uses Kubernetes? A few people. Cool. So Kubernetes is just a way of taking your code that you've got running in your service, wrapping it up inside like a mini operating system, which is a Docker container, and then you can run that on a bunch of servers. It's the basic idea. And the idea is you don't care where your service runs. It might be on that server, it might be on that server. You don't care, you don't know. But what you'll have is multiple copies of that server running. So where Kubernetes is great, and Amazon has ECS as well, and Google has their container platform too, you can say, hey, I want to keep 3 copies of this dog service running. But if you've got 3 copies of a service running up there, so it's going to say, yep, I'm going to do it, but I'm going to register them with a dog service. And the reason you want to have something like a dog service or like a router or a load balancer or something in front of it is because those containers, those instances of the dog service, I'm going to be running 3 copies at any given point in time, may go away. They may come back. I may upgrade them. I may upgrade them in a way that I take A offline, upgrade it, and replace it with a new version of A, and then I'm going to take B offline and then replace it. That's a round-robin update. I could do blue-green deployments. There's all sorts of fancy things I can do to upgrade my services at runtime. But if you put a dog service in front of it, then it sort of acts as a buffer or a gateway or a load balancer or reverse proxy, whatever word you want to pick, that actually hides that implementation detail. So then you can have something like an ingress router that I can make a request to my Kubernetes cluster for get dog, and it knows how to route that through to the dog service. I can then spool up another service like a cat service, but don't care about cats, so I'm just going to run one of those. And, then I'll have my cat service. So, services have IP addresses. So one of the things you don't want to do in microservice land is hard code your IP addresses. And if you think, who would ever do that? I could name several companies if I didn't have NDAs. So lots of people actually hard code their IP addresses. There's lots of solutions to this problem. But when that service dies and goes down in a ball of flames, when it comes back again, it's going to have a different IP address. And so what you want is what's called service discovery, where services, as they're actually starting and restarting, you get buffered from the fact that all their IP addresses are changing all the time. The other big advantage is the dog service will actually round robin the requests and load balance them across your services. And this is the sort of things that Kubernetes will give you for, I say free, except it's really expensive to pay the DevOps guy bill every month. Some other examples of things that can do this is Mesos, which can also run containers in this kind of way and give you all these kind of features. And also Istio, which is a thing called a service mesh. And if you want to look at something that's really going to keep you up at 4 in the morning reading manuals, it's awesome, but it's really hard, but theoretically makes it really easy if you can make it work. Love it. Don't think I'll use it anytime soon. Doesn't solve a problem that I have. But effectively, if you're into this kind of stuff, go look at Istio. It's pretty cool. At a high level, it's something like this. So the terminology in Kubernetes is you have traffic coming into an ingress router. It can give you different domain names that map through to services, and then those services talk to pods. And pods are an instance of your software that's running. And those instances of the software are all Docker containers, so they have your runtime language like Node or Python installed, and they'll have your operating system like Ubuntu or Alpine or something like that. So what's interesting, we had earlier on a big blue box up there. I'm like, hey, magic happens in here. There's a lot of things that that ingress router has to do. Now you need to know about to run microservices. So it's an intelligent router, it's an API gateway, reverse proxy, it's a load balancer. It does your SSL termination. If your services need to communicate to each other internally using SSL, for example, you've got a HIPAA compliant service, your microservices internally have to communicate with SSL, then we'll actually manage encryption certificates for all of that for you using Let's Encrypt for free if you're using something like traffic as an ingress router. And the pods are just instances of your service. So some good more rabbit holes to go down would be the Nginx, traffic, and HA proxy. They all have different feature sets around load balancing your microservices. I'm a fan of traffic. So far, it's treated me pretty well, but I've seen it fail real hard with 300 services in inventive ways. So I've also seen Nginx fail. I've seen all of them fail. Well, not HA proxy, but that's just because I haven't used it, and I don't know anyone using it. But anyway, things will go wrong. You have to plan for failure. So what you end up with is a virtual container environment for running instances of your service. That runs on some servers, so you might actually have 3 services and 9 pods running on 2 servers. And you want to have at least 2 servers because if one dies, you want to actually still be able to keep running. So generally, you want to run 2 or 3 servers minimum for a Kubernetes cluster. Most people run 10 or more. Larger companies in town that I know of are running like 50 to 100 node clusters. So. But then another rabbit hole to go down is now you've got to get your CI/CD working into these clusters. And this, we've spent 6 weeks building this. So now you find yourself, getting GitLab to build Docker containers, to upload them to Amazon ECR, to deploy them with Argo into your Kubernetes cluster, and then automatically monitor the deployment. We got that working yesterday. Felt really good, finally. Then you've got other things like Helm that'll do things like, hey, install Redis on my cluster, and it'll just magically take care of it for you. So I hope you notice the number of logos that are coming up on the screen, because you have to learn how to use all these things now. All right, let's talk about circuit breakers. So I've got a dog service talking to a bone service. Everything's happy. Except I get one failure. So, it's probably a glitch. Just retry. I got 10 failures in 10 seconds, so that's reached my failure threshold. So what I do is I trip the circuit breaker, and that actually cuts the traffic off from service A talking to service B. Then I'm going to have to restart the bone service because it's just not responsive to my health checks. while it's restarting, I'm going to return a default bone. So an example of this would be Netflix and their recommendation engine. If they're experimenting with their recommendation engine, for example, and this is all in that Mastering Chaos talk, if they're experimenting with their recommendation engine or it just fails or something goes wrong, they'll trip the circuit breaker and they'll return just popular movies. The service won't stop working because there's a problem in the recommendation service. That also lets them experiment. I can try out a new recommendations engine that may or may not work, and if it fails on a portion of my traffic, oh well, they get a default movie recommendation. Whoop-de-doo, I can still watch movies. So in the meantime, I have to wait for the service to restart, and that might take some time. Like restarting a Node.js service takes usually 2 or 3 seconds. Restarting a Python service, 2 or 3 seconds. Restarting a Java service, a couple of minutes, depends. But different languages just start at different rates when you're doing a restart. And different variations of Docker, by the way. I'd recommend Alpine Linux, by the way, if you want to just launch containers really quickly. Alpine Linux, if you can find that variation of a Docker container, go that way. Yeah?
Who's responsible for leaving the bone service to know a default bone was created?
Say that again, sorry?
So I'm assuming the bone service has its own data.
Mm-hmm.
The bone service should know that the default bone was created.
No, it's usually just request at that point. You wouldn't allow it to change data, so you'd flip into read-only mode. It'd be like having a MongoDB cluster and losing 2 out of 3 nodes. You'd sort of go into read-only mode at that point. That's how I'd code it anyway. Then what you want to do is test connectivity. So you want to start trickling some requests through to the service when it comes back up again. Because if a service is coming back up and you hit it with 100,000 transactions a second, it's probably going to die while you're bringing it back up again. So you have to give services the ability to actually gracefully restart, and you start to trickle traffic back to them. And then once you have some threshold of a certain number of requests coming through, you'll actually just get the service back online. You'll keep returning default bones until it passes it. And when the test is done, you'll open the circuit breaker again, the traffic can flow. Hang on half a second. So it's actually on the dog service to implement all of this functionality. If anyone knows of a good Node.js circuit breaker library that doesn't suck, please let me know. I have not found one. I've had to write my own on all of this stuff. I believe there's probably one out there, but I haven't found one in Node. So there's some great ones in Python. There's some awesome ones in Java. There's some awesome ones in C#. But it's the dog service's responsibility to actually maintain the circuit breakers, unless you are using something like Istio, which will handle all of this for you. So what you can do is delegate that circuit breaker functionality to your infrastructure if you have a service mesh. So that's part of the reason why if you're writing lots of circuit breakers and you're finding them really painful, go look up service meshes. But then you'll be reading Kubernetes documentation about sidecars at 5 a.m. Question?
Yeah, when the service part of the circuit breaker is popping, does the dog service send a bunch of health requests over to the phone service to see if it's response, or how does that actually?
You could do it that way. Generally, when it trips, I just keep trying to retry the same request. This is how I code them. I'll just keep retrying the same request in triple mode. You could call the health check endpoint, but I try to avoid the services knowing about each other's health checks. So yeah, you could do it that way. You'd also actually have it call your infrastructure and ask your infrastructure if it's healthy. It's another way of doing it. Prometheus generally will have that information. You can call it, get it out of there. Yep.
So I see how this would work with two services where one directly calls the other.
Mm-hmm.
When you have something where something goes through like a
Mm-hmm.
messaging queue, and then you have subscribers to that, how does that change the way that this?
I don't generally code them when I've got a messaging queue and I'm using an asynchronous service. Okay. So where you get some interesting problems, though, is when you have like a long-running process that's got a UI component to it. So I'm going to register a new user. I want to know that it succeeds, but there could be a service that's off some way down and everything's like distributed with queues. You have to have something like a request ID that you can poll to see whether it's finished. And so you're listening to see whether there's a message that this transaction is finished. So it becomes difficult because you're trying to orchestrate, you're trying to plan how to get a whole bunch of things to react to changes. And the trick is, how do you know you're done? And you can set it up with request response, and that works well. The problem that I have is, how do you debug that? It's really hard to debug it when it goes wrong, because your logic is now split over 19 different services, which is one of the reasons I like mono repos, because I can find stuff. If you have that in separate repos, it's a nightmare to find. So yeah, it's hard. But generally, I would do it by having a synchronous response coming back from the service and just poll for, like, is this done yet? Are we there yet? Are we there yet? Mm-hmm. Yep. I've not tried to use it, so just too many moving parts. Saga Pattern has a central coordinator that you can all the logic to debug it. So that makes it easy to debug. But the amount of I tried doing it once, and just in a test thing, and the amount of coupling that was in the code, I'm like, I can't deal. So I went down the messaging route, and I learned that way of doing it. Honestly, the Saga pattern looks really good. Probably should spend some more time with it. One of the problems about learning container orchestration systems is the learning curve is crazy. That's the learning curve for Kubernetes. That pretty much reflects my experience. If you're using something like Amazon ECS, you're going to spend all your time debugging this stuff in the Amazon console. It doesn't get any easier or harder no matter where you debug them. There's just a lot more things to learn with Kubernetes. But it really doesn't get any easier, unfortunately. If you go with something like Fargate, that's great, except you're going to try to run 19 copies of microservices with 2 each. That's 38 instances. Smallest instance size you can usually buy is like 0.5 of vCPU. You're going to be paying for all this capacity you're not using that you could run on 2 Kubernetes nodes. So just for money, it actually works out that if you've got more than about 10 microservices, Kubernetes is cheaper to run. But then you've still got to find someone who knows how to run it, and it really is like that. If you haven't learned it yet, go learn it. You'll have fun. And you got to do all this stuff too. So API documentation, authentication. How do I authenticate a request across a cluster? It's a whole rabbit hole there. You can do that in traffic with a piece of middleware. Distributed authorization. So I have a request come in, goes into some service way down the stack. Can this service succeed at this request for this user? Does everything have to call the user service? It gets really tricky. So how do you actually salt enough information into your headers to be able to authenticate requests without calling back to the service? It's kind of tricky. So that's actually something you have to go design. There goes 2-3 weeks of your life. So intrusion detection, distributed transactions, auditing. If you're in some kind of regulated thing, you have to be able to audit every single thing that happens. Once again, Elasticsearch is your friend. And finally, hardware. Running this on something like a Kubernetes cluster, you can probably get away with running 30, 40, 50 services on 2 or 3 nodes. It's pretty easy. Just lots of memory. So long as you don't max out your CPU, it's actually not that hard. Kubernetes will save you a lot on hardware, but it adds a lot of complexity. If you're going to try to run something like microservices on individual EC2 instances, good luck. Can't wait to see your Amazon bill. If you're going to try to run it with something like Fargate, once again, there's a minimum CPU size you can buy. I've generally found that doesn't work for my services, so yeah. Yep.
My curiosity is, do you have like a rough rule of thumb for when Kubernetes becomes worth it, which is basically when hardware costs start outweighing the cost of putting some of those?
Yeah, I did some math. It was like about somewhere between 6 and 10 services and a couple of databases. Once you get past that, Kubernetes made more financial sense. But it depends on where you are. Like, I'm in a startup now, so we want our AWS bill to be less than $1,000 a month. I mean, if your AWS bill is $60,000 a month, you're not going to notice any of this, and you're going to want to do Kubernetes or something like that. It just depends. Is unfortunately the real answer here. You whip out a spreadsheet and do the math, but we figured out, we compared ECS Fargate running EC2 instances with Kubernetes, and Kubernetes was cheaper to run microservices. If you're going to run a monolith, I just run a couple of EC2 instances, call it a day, or a couple of ECS containers, call it a day, and that's cheap. Cheapest way to run it I could find. But once you get past like 10 services, the math changes, or about 6 or 7 is where the math changed for us anyway.
So how long is it going to take you guys to figure out your support
I don't know, I'll wait for something to go wrong. I'll wait for the pager to go. I'm not sure. So that's the problem though. Actually, thank you for leading into my next slide. On the left is all the things you have to do now that you didn't have to do before when you were running a monolith. So monolith's either working or it's not. It's pretty easy to monitor. It's either up or it's down. But once you have things like partial failures and things like the network involved, things go wrong all the time. And if you think it won't happen to you, it will. If you think that EC2 node won't die because Amazon's reliable, it's not. I've had one fail. I've had multi-node Redis clusters, have had Mongo nodes go out. Stuff fails in production, in reality, all the time. Plan for it. Assume it's going to happen. But you have to do all that stuff on the left. And you've also read the manuals for all the things on the right now. So when people talk about the microservices cost or the microservices tax, this is it. It's complexity. And remember now, I'm actually monitoring, let's say, 21 databases, 3 message queues, and I've got 19 code bases. And I got a team of 20 people. Yay. So once again, if you have the sort of problem where this makes sense, which is I got 40 teams or I got 10 teams, definitely do this. If you got 2 or 3 teams, think really carefully before you go do this. You might be better off with just a 3-tier architecture, front end, back end. And then when you're super successful and you've got money rolling in, you've got 100,000 transactions a second hitting your gateway, yeah, you might panic a little bit, but I'd rather actually have that problem than try to build all of this up front. So taking the rabbit hole. Basically, the biggest challenge is your data. It's the relationships in your data, actually, that's a problem. The thing that I've actually found, if you get good at doing NoSQL schemas, doing microservices is pretty easy. They're basically the same problem. How do I set up a schema with no foreign keys? How do I set up a bunch of services that can only communicate with events? Basically the same problem. Domain-driven design is absolutely your friend. The second biggest challenge is productionalizing your services. I got that phrase, productionalizing, while I was working here at Slalom. You know who it's from, maybe? I don't know. Brian. But the thing to keep in mind is that the infrastructure and the runtime are inseparable for the services. Where you run the services and how you run them has a lot to do with what you can actually do with microservices. Alerting, monitoring, health checks, centralized logging, tracing, you have to have these to even get in the door. If you don't have these, the first time something goes wrong, you'll be going, I don't know. And then you're going to go off and build these. Service discovery, circuit breakers, load balancing, and routing are things that I would recommend you have from day one, or you avoid having your services need to talk to one another at all. The best microservices are the ones that don't need to talk to anything. Great example, images service. A photo service, all it needs to do is dump some stuff into a bucket, pull some stuff out of a bucket, and maybe draw some thumbnails. Yay. That's it. That's a perfect microservice. Pretty much need to be doing CI/CD, because keeping track of 19 code bases and getting it reliably into production, you won't get it right. Something will go wrong. You need everything to be testable, because you need to make sure your contracts actually stay in sync between your services. You actually might find yourself figuring out how to do TDD with messaging queues, which is fun. So we did TDD with an AMQP service last year. That was tricky. And you need to have automated DevOps. Plan for failure and design for eventual consistency. So why do them? Number one reason, teams. Microservices are really a pattern for solving a people problem, not for solving a technology problem generally. You're trying to scale the number of developers you can throw at a problem. You can avoid coordinated releases, but once again, that's a people problem. You can reduce your time to market if you have a bigger team. If you have a smaller team, it's actually going to slow down your time to market. You can scale cost effectively for load. This is one of the reasons as a 10-person startup are actually doing microservices. I have one microservice that's going to be taking SCADA feeds, and it's going to be getting hammered with 50 to 100,000 transactions a second per customer. So I have to be able to scale that service to be cost efficient to run, to be able to dump a ton of data into Elasticsearch really quickly and just pipe a whole bunch of data in. The rest of my services, I'm going to have one copy of them 2 for backup running, and I'm fine. But I'm going to have one service that's going to be hit really hard. Then I have an analytics service that's going to have to be in Python because we're going to be doing some machine learning stuff and yada, yada, yada. So I got different tools for the job, and that's the only reason I'm doing it. And originally I thought, well, if I'm going to be doing that, I may as well break the services up some more. I did that for about 8 weeks, and then I put them all back together again. But does let you actually use your favorite languages. Important safety tip, don't let every team use their own language. That gets out of hand really quickly, because if you're on call and you're reading Haskell code for the first time at 4 in the morning, that's not a good thing. It does force loose coupling. You can build a monolith in a service-based architecture that has every service owning its own database that's actually in the same code base. And we are trying to do that now using Nest.js, which actually forces dependency injection, forces data separation, and forces us to keep our code bases separate. And we're trying to code it in a way that we could break it into microservices if we ever have the problem and get that kind of loose coupling. I've not seen too many frameworks and languages for back-end development that let you do that. So Nest.js is my current favorite stepchild for that. Yep, we're using Nest.js and then Nuxt.js. Like, that couldn't get confusing. And the last thing is evolutionary architectures. I can actually throw out any one of my services and write it. So we've got an image service we're writing in Node. We're just in the middle of writing it right now. If I decide I want to just ditch it and throw it all in a Lambda and stick it up in AWS, I can. I don't care. Because it allows for that evolution of architectures and moving things around. Why that idea? Unclear domain. That's the #1 reason you don't want to do them. Startups shouldn't do them. Unclear product market fit. If you're not at product market fit, don't do them. They're a scaling problem generally, not an engineering problem. Can't pay for DevOps after launch. That's what's keeping me up at night right now. Can't afford the hardware or the software. This is an interesting one. Node isn't awesome for microservices. I'm learning the hard way. Java's really good for it. C# great for it. Python's threading model's a little weird, but Node's threading model's kind of unique. And so doing something like a correlation ID across requests, just because of the way threading works in both older Python before async AO and Node, is like actually kind of challenging to get something like a distributed trace working. So there's been some challenges in using a language that wasn't necessarily designed for microservices. We got there, but it added, an extra week of researching and trying stuff out and making sure it actually worked for real. Some languages are awesome at it. Some are not so great at it. Your language might not be suited, so do some research before you go try it out. And definitely don't do it because it's trendy. Terrible, terrible reason. My recommendation, build a monolith, or create some mini services. Don't try something at the bounded context level, not at the aggregate level, but definitely learn domain-driven design. This concept of a sacrificial architecture. You build an architecture that works, use in production to learn what it is you should build later on as you scale. Martin Fowler has a great article on sacrificial architectures that's worth reading. The biggest thing is avoid premature scaling. All of us want to have 50 servers, but most of us don't have that problem. I would, as you're implementing microservices, I would go with whatever language you're the most familiar with and use that. Don't add in new databases and new languages at the same time. It's too much stuff to learn. Remember that big list before? You have to learn all of that. So try to keep your languages simple. Simplify your tooling. This is what we actually settled on. I'm still in the air about Argo, but we're using GitLab for absolutely everything, directly into EKS, Terraform to automate our infrastructure, Helm to launch things like Redis inside of our cluster and Elasticsearch. And we're using Elastic APM and Beats, and we're just using their off-the-shelf cloud product, which does almost all of our monitoring in one tool. That replaced Prometheus, Grafana, Sensu, M3DB, and Redis with one tool. And then a big hard no to integrating anything in the database layer. So services either communicate with API calls or through messaging. Something else I'd recommend for anyone that's exploring microservices is look up event-driven architectures, so event sourcing and CQRS. It's an interesting way of thinking about systems and databases. Some of the biggest companies in Denver are using event sourcing and CQRS quite well. We are actually building our entire product on event sourcing and CQRS. It's hard, but it's totally worth it. So whole talk on that. And actually there's a bunch of really cool talks online, and the guy doing it's super angry, but they're really good talks. And if you know who I'm talking about, you know the guy. But I've got links to the Angry Man's talks as well in the end. And then last one, put the training wheels on and go try this stuff out. Do we have time for a demo? Maybe not. All right, I might flip through the last few slides and then just sort of come back quickly. I don't have much of a demo. Those are the books, by the way. If you're interested, I can leave it up for a second and you can take a photo. But
Maybe send out the slides.
yeah, I can send out the slide deck. Oh, cool. Now I want to leave time for questions too. This one, domain-driven design distilled, awesome. And this one, designing data-intensive applications, is amazing. If you have a data-intensive problem, read that book. Awesome book. Most of the way through that book, it only came out a little while ago. Good for sagas, good for the DevOps side of running them. And then that last one, you may or may not find it good. I didn't, but I already knew the stuff was in the book. But yeah. Some videos. Go watch these ones. The one that I actually thought was the most interesting is this idea of compositional UI. So your UI is actually owned by the microservices team. That was really fascinating, because I always thought microservices would stop at the API, but having the microservices team own everything through to the front end, or one little portion of the web page on the front end, never would have thought of doing that. And then a bunch of articles from Martin Fowler. He's not the only person that writes about these, but he will give you all the warnings that you probably should pay attention to. Yeah, sorry, I'm moving around. So that's about it. I don't have a whole much of a demo other than I wanted to I was hoping originally, I thought, how hard would it be to sit down at my computer and actually go new Node app and then build a microservice in front of everybody? So I sat down 2 weeks ago to try to do it, and I'm not done yet. If that gives you an idea of how many steps are involved and how many little things can go wrong that will actually stop it from working. For example, turn my little mouse on here. If you have, so I set up this like little example where I wanted to build a dog service and a cat service, and then I wanted to be monitored with Prometheus. I wanted to take my logs with FluentD and send them through to Elasticsearch. Okay, so my Prometheus is scraping my metrics, and it's dumping all of this stuff into here. So I've just got a counter that's been going up over time. I'm actually got Grafana that's actually pointing at, that's been, like the whole time I've been doing this talk, I've been running this in the background. And I've been collecting metrics in the background. And now I have to go set up alerts to everything else. So now I find myself having to read the Grafana manual. I have to set up Swagger UI because all of the services are communicating to each other. So now I have to know what's going to be in there. So I've set up Swagger to do all my API documentation, as well as I have really detailed READMEs that are really, really, really long. And then I've got Kibana set up, pulling all my logs back straight out of all of my services, both my traffic logs and my dog service logs. All in, file new node project to make all these things just work together. Probably got about 50 hours in this now. I had to do this anyway because I wanted to be able to run our whole stack locally on our machines rather than only in our Kubernetes cluster. I wanted to be able to run it locally in Docker Compose. But most of this stuff gets hidden from developers because you end up waiting for the DevOps guy to do it. But when you're the DevOps guy, you got to do all this. It doesn't come at a zero cost. So just before I started the talk, nothing was working, and it turned out that I had one of my ports was wrong. The service that I was starting my node service on was different to the port that I was listening on in traffic. And I didn't have, the auto discovery was finding the right port, but my node was sending my node service was listening on the different port than what I exposed in my Docker container. Logs available to diagnose this, 0, because I was sending them all into Elasticsearch. But I haven't actually, because it didn't start, nothing went to Elasticsearch. So this stuff's hard to get working. It's really hard to get working. There's a few, in the Python world, there's a thing called Python full stack, like D'Angelo full stack. Some guy's actually written a Python service and Docker and monitoring and everything all in one big Docker Compose file. You just come in and go Docker Compose up, launches a whole bunch of things, and you've got a fully maintained service in Python. For Node, I haven't found the equivalent. I'm probably going to, when I get this working, I'll probably publish this up to GitHub because it's really painful to get this stuff working. But yeah, so that pretty much is the extent of my demo. But to get all that stuff working was a lot of work because I'm spending most of my time trying to figure out how to match ports together and get things to talk to one another. And you spend most of your time doing that. And debugging is a lot of doing that. So there you have it. I think that was it, other than, oh yeah, questions. I have some suggested questions. So it's my suggested questions. Yes. Oh, yeah. I actually, it's really weird. Like, I have pretty terrible insomnia, and I seriously can read a Kubernetes manual at 3 a.m. I don't know why, but like reading the traffic manuals, and for whatever reason, traffic is fun. They're a really fun team. Reading their manuals at 3 a.m. is awesome, but the amount of reading you have to do to make this stuff even work at all is insane. So either hire a DevOps guy who's going to do it all for you. The problem is if they ever leave, you have to figure out how to run it yourself. But it's actually kind of cool to figure out how to make a big, complex, distributed system work. So I find that an interesting challenge. The last one's an interesting one. I don't know how many 4 a.m. Slack conversations I've had, and I don't know why it's 4 a.m. But it seems like Kafka fails at 4 a.m. There must be some like cron job that basically decides that a node failure is going to happen at 4 a.m. and like your producers are all going to get moved to different nodes and like simultaneously, and yeah, it's weird stuff happens at 4 a.m. in Kafka. I really like it for some reason. It's the thing that's given me the most pager calls. And I was like VP of product at the time, so I was the one talking to the customer along with the head of customer success, so it wasn't fun. So, yay. Yeah?
So I have a question regarding coupling. Let's say you have two microservices that are communicating events over a message broker or whatever, Kafka, doesn't matter. You define a model for the event. Right? You've got a schema for it, whatever. How tight do you want the validation on that model to be?
Loose. I like it loose as possible, is my answer. There's a few ways to do this. One is you send the object that changed when you send the message, and you just send the whole object through. Another way is you can design a special schema for the event, but then try to make the listener as fault tolerant as possible. Another way is you don't actually send the object. You just send the fact that the event happened, and then you have the receiving service make a get call only into the sending service to go and get the latest version of the object if they care. I've seen a lot of teams, well, not a lot of teams, I've seen a couple of teams do that successfully. It's more common to send the object and try to have complete decoupling between the services. So I will tend to have something like dog changed. I'll have a property called data, and I'll just dump the entire dog object into the data field as the payload. And I won't try to strongly type anything. I'm a big fan of like, make it look like it's mostly working, because for the most part, that's good enough. Worked for Google for like 20 years, so. Yeah.
So you've never, how about integration within those messaging sets?
You can do it. I try to avoid it at all costs because it just adds a lot of problems. I've always just tried to keep a really simple eventing model though, where it literally is event type, date, producer ID, producer service name, correlation ID, and then data, and you just blob whatever object it was into that. I try to keep them really simple. There's a whole big section in, I think it's, I know he's got a whole bunch of stuff in it, but I think one of these two books has a whole section on designing versioned data model things. I read it and like just vowed to try to never change them. Yeah, you can version them. I don't generally like doing it. A big anti-pattern with microservices to version the API contracts for the services. So, because then service A becomes tightly coupled to a particular version of the contract on service B. So a big anti-pattern in microservices to use versioned APIs because you'll end up supporting them pretty much forever. So generally you have one API, you change it, everyone has to deal with it. And you catch it and test generally. So that's the general recommendation. I've sort of generally stuck with not versioning them.
It feels like that would break some of the not prediction, but the actual subversion concerns there because
To version them?
if you don't version them.
Yeah.
Because then you have to use more than one microservice at the same time
Mm-hmm.
in order to achieve. And that feels like, especially with the large number of microservices, you want to be able to reuse the ones we tested and completed.
Yep.
Then you use the dependent ones later.
Yeah, you can also like do a like a canary deployment and then launch your new microservice and then eventually cut over to it and do blue-green, that kind of thing as well. Generally, I will do that rather than version. So I'll actually completely rewrite the service as a whole new service, and then I'll start sending traffic to the new service, and then eventually do it. It's like a mini strangler pattern inside your microservices. So, yeah.
So that's actually a great lead-in. Have you used the strangler pattern before in refactoring a monolithic into microservices?
Yes.
If you have, do you have any tips for how to do it not wrong?
Yes, I do, and I actually am not going to claim, I'm actually going to point you at a book, and then I'm going to tell you what the answer was. So it's actually in this one, Monolith to Microservices, great book, only got it on Sunday, right in time for this talk. It actually has a section of how to pick things in the strangler pattern to pull out. It's actually, you want to pick the thing that has the least number of incoming dependencies and outgoing dependencies in particular. So it'd be something like an email notification service. Pretty much that thing's just going to send some emails. That would be a good thing to pick off and move out to a microservices first because it doesn't have complex interactions. The problem with a monolith is over time, there's a lot of connections inside the monolith and everything talks to everything else because it's just easy. So you've got to find something that's the most independent, and the recommendations, this book has been awesome on that, but generally you find the thing that has the least amount of coupling already and pull that out. So I wouldn't, usually in Agile you find the hardest, biggest, riskiest thing and you start with that. In this case you don't want to do that. You actually want to find the thing that has the least number of dependencies and start with that and just keep chipping away at them. At one company where I worked, that's pretty much how they broke up their monolith. They had a huge Java app with tons of code and just took all the non-essential services and just kept working their way back until the only thing they had was this like essential ball, but it had a lot less dependencies at the time they refactored it. So you keep breaking dependencies, but chip away from the least number of incoming dependencies first. And then if you've got something with no outgoing dependencies, like an email service, depends on like SendGrid or something like that, whatever. But it has no outgoing dependencies on other services. So that's a great candidate. And start from there and then work your way back through the stack. But that book, everything that I ever could have told you is in that. It's awesome. Really, it's got a whole section specifically on that question. Chapter 3.
Question about so you mentioned when not to go to not to go to microservices. So say basically someone like the team lead is interested, but we kind of hit each, why not to go to microservices. Is there a good way to, I guess, sort of talk them down or maybe try and push towards a certain path?
Yeah, good question. I'm not sure. I mean, it's pretty trendy right now. It depends entirely on the team lead. I mean, the question you really want to ask is what problem you're hoping to solve with them. And if it's not one of the problems that really microservices solves, and then also the question would be like, how are we going to do all these things? Like, how are we going to do alerting? Like, it's not free. Who's going to build all that stuff? So if you're like a small team of 10 to 20 people and you're going to switch over to, less than that, yeah, and you're going to switch over to microservices, you have to build all this stuff. Like distributed tracing's not free, and distributed logging is not free. You're going to have to set all that stuff up, and I'd want to ask who's going to do all that. So I mean, I started going down the microservices route because I knew I had to do at least 5 or 6. I'm like, I may as well do everything as microservices, and I backed out of it really quickly because I don't want to have to write metrics code 10 times. I'd rather write it 5 times. So, because theoretically, you don't reuse your code. I mean, you can set up symbolic links in your repo if you want and try to reuse code that way, but the whole point is not to reuse code. That's how bigger companies get away with huge mono repos, is they don't share code. So, I don't know. I don't have a good answer for you, unfortunately. Generally, it fails pretty hard. So, I remember seeing one move over to microservices and Kubernetes, and like 7 months later, they didn't have a single call happening in production. So, it can go bad. Yeah.
Do you have any ideas on when it's appropriate to use serverless versus Kubernetes?
I'm not a fan of serverless, so I'm probably not the right person to ask. I don't like it because of the lack of debuggability. That's my thing. I don't want to have to be debugging my code in a web browser in AWS console. That's why I don't like them. They have their place for certain things, like we're going to use them for like a thumbnail resizing service that a Lambda will kick off every time I save an image to an S3 bucket. It'll just run and resize the image. It's great use for it, but that's something that generally doesn't go wrong that I have to debug. But I like being able to debug code in production because that helps me keep everyone happy, especially the customers.
I definitely agree. I was just thinking somebody might be able to change my view.
Yeah, I'm not that person. I mean, I don't particularly enjoy Kubernetes either, but at the same time, when I looked at ECS or Fargate or running EC2 instances and everything I had to do to make that work with 10 services and 2 copies of each, Kubernetes was just easier. So, yep.
Say, you start out with your monolith over time, you just, for one reason or another, it becomes highly interconnected with dependencies, and you want to go to microservices. Would you rather kind of decompose that monolith into microservices or kind of rewrite the entire thing into microservices?
I am going to give you the advice that I just didn't take of myself. I would probably try to pull off bits of functionality, if it's possible. It's a thing called the strangler pattern. I would take pieces of functionality and convert them bit by bit into microservices. So I'd take, say you had 50 features, I would take 2, 3, 4 of them, move them into their own microservices or move them into one microservice and just start there and do it over time. Doing big app rewrites will take 5 times longer than you think, and especially when you want to do all this best practices microservices stuff while you're at it, while you're trying to refactor your code, it's a lot to chew. I would do it as a refactor. Having said that, I just made the call to completely ditch our old version of the product when I took over as CTO in this new position that I'm in now, largely just because the last version of the code, there was nothing salvageable really in it, in my view. The data model was completely wrong, and the data model had to be rewritten. So that meant throwing the code out. If it was just that it was coded badly or it was a bowl of mud, then I probably would have kept it if the data model had been right. Because I'm not having fun now trying to hit dates rebuilding a greenfield service that does effectively what the last thing did, but without any of the limitations. It's not fun. So I would take a working service, keep it working, because if you think it's going to take 3 months, it'll take 6 or 9 or 12. unless you can't salvage the data model. If the data model is completely balked, then probably need to throw it away. That's my 2 cents. As always, though, it depends. Yeah.
So one of the big advantages, as you said, in this is that you can deploy and get code changes out very frequently on microservices. How do you convince the business that you can do that without them freaking out? Because the problem that I had on a recent project was that we built a microservices system and the business never gave us the okay to do those daily deploys. They made us wait until full QA cycle was complete.
I might know who you work for. So I'm going to actually defer to this again. This is an interesting one because this actually is a change management problem. It's a whole section on change management in monolith to microservices. And one of the key things is getting the buy-in from the entire organization and actually preparing everyone in the organization for change and making them excited about the change and about the advantages of the change before you go off and build a whole bunch of stuff. So having a microservices environment and then doing 6-month deploys, kind of pointless in a lot of ways because you didn't really buy yourself anything. You might as well just refactor to 3 or 4 services to make your code more maintainable and call it a day. You really have to actually work on the people aspect of this way in advance and take the change management side of it really seriously. There's a change management framework called ADKAR that I'm a big fan of that Slalom here actually teaches our customers. That I would look up the ADKAR framework for how to actually get those changes, get the business to change their mind over time. And then there's another one that this guy talks about, Sam Newman, in the microservices book as well. But effectively, that's a change management problem, and you need to have the buy-in of the whole business, I believe, before you try to do it. That QA is actually bought off on person, like you might have 3 or 4 devs, a QA person, a product person, and a UX person on each team. And they work independently, and their software is independent. And that works incredibly well. You know, call it the Spotify model, call it whatever you want. That's the model, works great. If you have centralized testing, and everything has to go through some kind of centralized testing department, they want everything to be together before they bless a release, you're not really getting the advantages of microservices. You're going to be paying the cost without a lot of the advantages. Yeah.
I think one thing you can really emphasize there is you are emphasizing automated testing. So if you have rapidly reproducible tests that hit your major test cases within the CI portion, it's a lot easier to get by off because you can reproduce the number of problems and have done really detecting very quickly. As a corollary to that, keep in mind that you have to have environments that do allow you to have reproducible tests, and you may or may not actually have that. If you don't,
Yes.
it's a very painful situation.
I'm going to emphasize that again for the camera. You actually need to have an environment that allows you to have reproducible tests to be able to automate all of your testing. And that's actually a lot harder than you'd think. So all of our unit tests, for example, don't have database dependencies, so they all run. We have a problem now with our CI pipeline that we just launched that none of the end-to-end tests will pass because of some environment variable problem with Redis that we can't figure out yet. And we've been working on it for 2 days. I've allocated 4 hours on Friday to debug just that problem. So getting something that looks good enough that'll satisfy your testing people to even run automated tests and having the environment that can support that's actually challenging to build too. I believe you'll need to have end-to-end tests, load tests that run every check-in. At that point, you can get some buy-in from your QA group. But if your QA group is centralized, it's kind of an anti-pattern. You actually really want to have a QA person on each team. And that with each release, they'll QA it. All the automated tests will run. They'll do their manual QA steps or whatever else they're going to be doing as part of their QA process. And then when it's actually tagged for release into staging, it goes off magically into staging and it's done. And if you've decoupled your systems properly, that'll work really well. I mean, the other thing is it could be a sign that you actually still have coupling in your systems that you can't release independently if you have that many dependencies between your services. But you may not. It might just be centralized QA, which I'm not a fan of. A lot of places still rely on it, though.
We are now a few minutes past 8, and I want to be respectful of people's time. People are welcome to stay around and keep talking if you're
Thanks, everyone.